Hi, 8th graders. I am going to do your VNQ on metamorphic rocks. If you haven't watched the igneous rock VNQ, please do that first, as there's a little bit of background information that would be helpful before you do this metamorphic VNQ. Okay, so metamorphic rocks. I like to kind of start off talking about metamorphic rocks with breaking down the word metamorphic. You guys have probably heard of metamorphosis before, whether it's talking about butterflies or maybe you're looking at Pokemon. But metamorphosis basically means that things are changing and things are becoming one thing into another. Like with a butterfly, we first have an egg, then we have a caterpillar or a larva, then it goes in that cocoon, and then at the end it becomes a butterfly. And that's really similar to metamorphic rocks. Metamorphic rocks, as we can see at the first picture, we have another rock that's there, but it changes. It metamorphosizes, hence the name metamorphic rock. Okay, so that's just to sort of get us warmed up. You should be in lesson 2 of your DINB. If you're not there, please make sure you get there. Our essential question is, how do metamorphic rocks form? What are the 2 subgroups of metamorphic rocks? So that's our goal for today, and you should be able to identify the 2 subgroups of metamorphic rocks by the end of this lesson. As with the igneous rock VNQ, you're going to have a chart. As you can see, this chart's a lot shorter, but you should fill this out as this has a lot of the essential information. So we'll be talking about the metamorphic subgroups and the arrangement of grains. Then after the video is done, there is a slide for you to drag and drop these text boxes into the location that they would fit. You will learn this information throughout the VNQ. And then also you're going to have another image search similar to the igneous rock one. So in this image search, you're going to be looking up these 3 metamorphic rocks, and then you'll be highlighting which subgroup they belong to. Okay, so let's get started on the notes in the lesson. So I kind of gave you the little introduction of metamorphic rocks, but again, metamorphism is just changing. We're essentially what's happening is we are recrystallizing the crystals in a rock. Many rocks that are deep within Earth are very stable at high temperatures and pressures. So usually rocks, even if they have a high temperature and pressure, will stay the type of rock that they are. However, if something changes or the condition changes, we then get metamorphism. So metamorphism involves an action and a change in a rock's environment. So what could cause rock's conditions to change? Looking down here at the blue text, we can have plate tectonic activity, so like subduction can trigger rocks to change. We could have magma coming through the layers or doing intrusions like a dike or a sill. Maybe they get buried deeper, or really generally anything that's going to change the heat and the pressure of a rock will then trigger it to metamorphosize or become a metamorphic rock. So we have 2 subgroups or subfamilies. The 2 subgroups are foliated, which is kind of a weird word, foliated, and non-foliated. So you might want to type this in that chart if you have your DINB up. Foliated is the first group, and what this basically means is the grains and the crystals in the rocks, they have parallel bands or stripes. So if I look at it and this rock is changing, it's going to change so it has bands and clear stripes. Some examples of this is like slate or nice. I know it's kind of a weird word to spell, weird way to spell nice, but gneisys, nice. Anyway, but foliated, when we look at those rocks, there's clear parallel bands, and that is a foliated rock. And one way I think of this is foliated, like we're folding the rock and it's a nice folded stacks. It's not actually folded, it doesn't get folded, but foliated means that there's parallel bands or stripes. Non-foliated is the other subgroup. So the other subgroup is going to be the opposite, basically. Non-foliated, we don't have any organization, and Usually the rock still has the same grain sizes, but they're all kind of mixed up still. But what's kind of interesting is sometimes the rock might appear to be a little bit glossier, or it might look wet, because those crystals are all the same size generally. Examples of this are marble, quartzite, hornfels, but when you look at those, they kind of look a little glossy, but they're not very organized in how they look. So foliated and non-foliated are 2 subgroups, and make sure that you put that in this chart. So take a second to fill that out, then maybe double check your answers. Foliated, arranged in parallel bands or stripes. Non-foliated, you could say it's disorganized, glossy, sometimes looks wet. Now, a couple of things to think about is, can metamorphic rocks like metamorphosize themselves? And the answer is sometimes. Depending if you change the heat or the pressure or both, we might see these things change. But just know that like the deeper we go and the hotter it gets, we're going to have different metamorphic rocks. We also have to think about what was the parent rock and what was the rock that was being changed. So we'll kind of talk about that when we get to our ISM lab. But think about, hey, let's look, we have quartzite here. Maybe quartz was its original rock, because quartzite. There's some hints in the names of these metamorphic rocks, but we will explore that in our ISM lab in class that we'll do in a couple days. Before we go, I just want to talk and let you know that there are 2 types of metamorphism. There is contact metamorphism and regional metamorphism. So contact basically kind of sounds like how it is. Like this is, I'll move myself over here so you can follow along. Contact metamorphism is like the rocks are touching the magma, or they're really close to it. It's super hot. We don't necessarily have to have a lot of pressure with this one, but we have it's really hot and higher temperature. So low P means low pressure, high T means higher temperature. You can think about, how can we get contact metamorphism? Well, it can come from intrusions, or maybe there's some lava flow happening. And contact metamorphism happens in smaller concentrated areas. Now you might be thinking, hey, what type of subgroup am I getting with this one? You're getting non-foliated. So if you want to add that to your chart, you can say caused by contact metamorphism, but usually with contact metamorphism, you see those non-foliated metamorphic rocks. The other type of metamorphism is over here, is regional metamorphism. Regional metamorphism, the rocks aren't touching the magma at this point. So usually it's not as hot. However, it still is hot because it's probably deeper down. Pressure is kind of the greater influence with regional metamorphism. So we have a high pressure. We still do have a high temperature, but pressure kind of is a little bit more important. How does this happen? It can happen from burials, like more rock layers forming on top of older rock layers, or we have a lot of compression over a large area. Regional metamorphism happens over a bigger area, whereas contact is in a smaller area. So regional metamorphism, because we have all this pressure, it's going to create foliated metamorphic rocks. So we see those bands of those parallel lines in the metamorphic rocks. Trying to think, oops, I'm going to see if there's any other. Here's a picture of contact metamorphism. See that magma chamber. And here's a picture of regional metamorphism. Bigger area, pressure is more important. Okay, so I'm going to head back to this slide here. If you want to add some things about contact or regional metamorphism, you can. Remember, foliated is caused by regional, non-foliated is caused by contact metamorphism. But this is the essential information that you need to have. Don't forget to go back and fill out, oops, I went the wrong way. Oh my gosh, I'm totally going the wrong way. So sorry. Don't forget to fill out this slide here, drag and drop those text boxes to where they should go. And then doing this image search will help you kind of see what does it look like when a rock has those parallel bands or with their foliated, and what does it look like when they're non-foliated. Okay, so I'm going to head back right here just to end on this. Thanks for watching the VNQ. Do the other slides, and then don't forget to do the quiz. Have a good day.